Good evening.
So Mika said good evening, like you text me say safe, very strong. Not even good evening, sir. How you do? Good evening. Is when me do your Nesta? Talk to me.
No, sir, the mic did not take a while for load, so I'm never sure if you was hearing me.
Oh yeah. Good evening, honey. You good?
Yes, sir.
Alright, but that's how we until a little more come in. Go on to some work.
Sir,
Mm.
sir, is this something?
Say it again?
You did the edicus of something?
Yeah. You're not seeing yourself on it?
No, sir. Never check no. But
No
when I last
man.
checked, I didn't see.
No, sir. Tell me if you're not there because I did it. I did it. You check, let me check, and if it's not there, I can't put it there now, but I did it, man.
Not seeing it, sir.
I'm logging in to check. All right. What did it do? Yep, I sure did. I sure did, Miss Mr. Roo. All right, so guess what, no, Nesta?
Mm-hmm.
In my class, let me see if I can log on and show you here because I don't want anything to line here, you know.
Sir, I'm not think I
No,
tell.
no, 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 no,
Maybe
no,
I
no,
did the
no.
wrong login or something.
You're doing everything that is correct. I put everybody on. I never remember you. So that's my confession.
Oh,
So, it may tell you some more, show you some of the other students then, but somehow you just never got added. And I sat down and hold on. And I was saying to myself, say, boy, I add these students to the class, and nobody don't even say, thank you, sir, because any of them did respond to Edico. Why am I not seeing this? Okay. Any of them did respond to the fact that I got you guys registered. You just say, boy, people them there already, and they're there, you just say something to me.
so I text in the group the last time.
And that's what prompted me to go ahead and do it.
Okay.
But when I saw that message in the group, I was reminded this was after the last class, right? Last week Friday, right?
Yeah.
That was what prompted me to get up and go on do it, because me not like to you say after class on a Friday, we can't do nothing because me don't me beat. And then Saturday morning I have a class from 9 o'clock to 12:30. And then you have to do little rounds because place close 5 o'clock on Saturday and them things. So we go road Saturday. So I think when I saw your message in the week, I said, no. I need to get this thing done up. So I did it, but I totally forgot about you, and I apologize. So let me just all right. So
This meeting is being recorded.
All right. So I just disconnected that audio. So let me share my screen and show you. Say now, your teacher. I don't know what happened now. Why is it not coming up? It's not showing it. Oh, I was wondering why not coming up. You see the screen?
Yeah.
So you see, I have Ottilie there, I have Tony there, I have Dana, I have Tajay, I have Tiana, I have Rajay, I have Shani, I have Daniel. There is no Nesta. Talk the truth. Don't start out order. Never put it on at all. I apologize, my love, and I am going to do that just now. Um. Right, Nesta, you're there now. So go ahead and check for me, please, and let me know if you see yourself. Let me just go back and just check to see. Yes, you are there. And guess what, Nesta? You are registered, you know. You are fully registered, don't?
Yes, sir.
Mm-hmm. So I see. By the way, let me ask you, Nesta. We've never, since I've been teaching you, we've never had a face-to-face class.
No, sir.
Oh dear. So you know what I look like, Nesta?
I think so.
No, it's only this. This can't go on. Can't happen. I forgot plan something. I forgot plan something. I forgot plan. I forgot plan a Sunday class. I forgot plan a
Sunday,
Sunday.
sir.
Yes, ma'am. And we got Devon was going to eat ice cream and have one Sunday class. Even 1 hour. I forgot plan one Sunday class. Yes.
Sir, why Sunday?
By Sunday, because after you eat the oxtail and rice and peas, we need a little ice cream to wash it down.
I know me can't eat ice cream. Them
Why?
have vegan ice cream or dairy free.
You lactose intolerant?
Why, sir, the ice cream give me bad.
Oh
The
no,
dairy,
gosh.
I
Mm-hmm.
forgot hospital my toes that the
Are you
sinus.
serious?
Yeah, because I didn't know that. Well, I guess everybody them say have sinus, but it
It
infected
affects
my
you? Oh
yeah.
no. I know some people are like that. I know some
Mm-hmm.
people are like that. That means you can't drink milk then?
Sir, yeah, I get used to it though. Like, I not feel fit again.
Oh,
Yeah.
Yeah, man. Wow. Wow.
But
So,
don't get me wrong, you know, here and there, me
mhm.
eat a little ice cream and a
But that have to go on, you know. That have to go, that have to go on sometime. All right. So let's see if she's there because you see, there's another student who I don't put on, you know. Chanel Allison is not on it because neither. You're not seeing her on it. Look and tell me for me, please.
No, sir.
Right. And she has selected the course. So let me put her on because me not able for Shin. Nice student, but Shin gonna say, sir, you know, put me on. So you know what? Let me put on Miss Shin. I wrote her exam and submitted her exam paper and I look at the exam paper and I'm gonna tell you, you see everything I've done so far,
Mm-hmm.
it's on the exam paper. Nesta, all I beg you do, and for the rest of students who will listen to the recording sometime later, just go through the work.
Sir,
The,
what me I
the,
do?
paper, the paper is not bad. I set the paper, and I don't know if my paper is going to be used, but may I tell you, just go through everything what I do now, go through it because it did it. And then I can pass the course. What want to do else now? Are you practicing?
Yes, sir. I may use another approach.
Mhm.
So, how me learn? Well, in my meeting by writing it down. So
Mhm.
I start write it down and jot notes and
Very
you know if I
nice.
try remember because
Very
I've
nice.
never done that before.
Very nice. Like I
Yes.
was hoping that you do that because that's the best way to go. It's when you write, you will see what is happening. So yes. So Alison is there. Yeah, man, just do that, man. Me want you pass the course. Me want you pass the
I mean,
course, man.
it's my
Just
last try.
hello, you never try, you know. I know what man for follow.
Exactly.
No man, you can do it, man. It can happen. It is going to happen. Just come and just be very purposeful. Just do what it is that I'm doing. Because as I told you guys before, and I'm telling you again, what it is that I'm doing, I'm also taking a different approach. I am putting the big boys up front first, and then the little boys them are gonna come in last. So you see, I've done Newton Ramson with you already, and the problem that I have with you know the names of the something, but you know if you do them, but you have to go know what the name. So Newton
Yes,
Ramson
sir. Fine.
is the
Mm-hmm.
Newton Ramson we have done when we talk about the approximations, and you have to go to X1, the different iterations. That is Newton Ramson. It depends on the paper. It a go come. All right. Those are one of the big boys. I've also done McLaren's expansion with you, where you have to go differentiate over and over and over and over and over again. That the big boy did it. I'm
Mm-hmm.
starting a new big boy today because I've done those with you, so I'm expecting you guys to practice those. I can't stay every week, but come and have to do a different topic because if
Mm-hmm.
you do that, we're not going to able move on. So you have to make sure so you get the stuff done up. Today, I want to go through one of the other big boys and just do some more differentiation. And if you want me to do that, I'm good to go because there are
Sir,
two. Go ahead.
mm-hmm. What I'm saying, what I've realized,
Hmm.
the past papers really help. Like last semester,
Yes.
why, sir, God know that alone me pass.
Yeah, man. Yeah, man. They
Because
help.
I went through the past paper the day before the examiner, sir.
Hmm.
Everything come back.
Hmm.
Me know it
Hmm.
not happening in all cases.
Yeah,
Not
man.
the
But it
exact
help, man.
thing, them change the words, but are the exact thing.
Hmm.
That
Hmm.
alone make
Hmm.
me do that.
And I'm saying to you, um, that's the way to go. Tonight, I really want to spend some time on one of the other big boys because that that will come into two different questions that you know. All right. And if you're looking at that are like 20 marks, if it come the way we want it come, that will be 20
Mm-hmm.
marks for one and about 5 marks for the other. So I talk about 25 worth of marks. So everything that I'll do tonight, because I have to start that tonight. If I don't start it tonight, I'm going to do a disservice to you guys. I must start that tonight. There's another little one that I need to do, but boy, me can't wait until next week, God's willing, to do that little one there. But tonight, me really need to start. That. Matter of fact, go and go message another group for me now and tell them and say, well, when I come, When I come to class. One go message them for me.
Mm-hmm. Good evening, sir.
I was just about to say, if you don't come to class, good evening. And all you do.
I'm here, sir. I'm here. I've been here for a minute.
Okay, so you hear the conversation.
Yeah. Mm-hmm.
All right. So all I'm saying to you, Otto, is I wrote the exam paper. I submitted your exam paper. And as I said to you, the approach Nesta says she's doing is writing more and trying to see it on paper and putting in a little bit more work. Um, the approach that I'm taking is I'm getting the big boys out of the way first. The two areas that I've already completed, namely Newton Rampson and McLaren's expansion, them dead. Them dead. I don't know if my paper is coming back, but all I can tell you is the questions that I have submitted are questions that are there on the exam. Questions that I know if you guys put your head to it, you can do it. Tonight, I'm going to start another big boy, and that one is going to take me into quite a bit of marks on the exam. If you want to understand that, I will come marks it on the exam. So, me want to never come in and I want to do the work. Now, me understand Arthur, you and Nestor. Me understand um, the workload, and you and I have had conversations last semester, Nestor, regarding this course, and not Nestor, utterly, and Nestor and I have had conversations in the past about the calculus too. Me don't want to be afraid of it. I don't want you to be afraid of it. I want you to do the stuff. Now, let me start with Nestor. So Nestor is understanding, Nestor's concern that I am sensing is that she's able to do the questions, but she don't know what them name. She said, sir, I want something name. The one that I do before? I say, yes, okay, sir, I understand it. So Nestor, you need to know the names of the stuff. I want you to be able to practice more. So when you go into the exam and them say, Newton Rampson, you know which method we're talking about. Me know why you go turn fool and you say, which method? Because I know you know how to do the stuff. Because I hear in class and you're doing the questions and you're getting the questions right. Otto, I know I know you work hard, and I see where it is that you put out the effort, but sometimes I don't know what is happening. That um, I don't know if you maybe believe that you're understanding something, but you don't fully get it. I want the peer of you starting tonight. Any doubts at all you have with the question or with the area, with the topic, ask me. This semester, gonna have to get the calculus 2 out of the way. Gonna have to get it out of the way. We don't have much time left, but we have to get it out of the way. So please, me appreciate the two of
I'm
you so far.
working on it. I know my downfall is that it's not that I don't get it. I get it and I put it down and start focusing on other stuff. And then when exam time comes, I just do it for the last minute. And it's like, when you trump up everything all at once, it's like, I remember it. So, my fault or my own fault. So, I take a different approach.
Yes, man. And I love when I hear that you guys taking a different approach, because guess what? The different approach is, well, you can't do things the same all we are expect to get a different result. So when you start something different, yeah, it says to me that, man, them students are really serious. So just do what it is that you're supposed to do for me, please. I beg of you. Let me just check on something. Arthur, you have not yet selected the course. You need to go to the
I have to
area.
go back because when I was selecting my course, remember I was saying it was not there. So I need to go in.
Yeah, man, go back and check now because.
Yeah, because I remember I reached out to you and told you that I was not able to.
Yeah,
I did
man.
not see it. So I'm gonna go in and select. That was the only course I didn't select.
Yeah, man. So see if you can do that for me. See if you can try it now while I wait on the others to come in.
Okay, okay.
All right. Thanks, Nesta. So we put it in the group to, classes in session now. There are some students that are you seen on the screen that Tiana and Dana that I need to touch base with because I don't think that Tiana did say to me that she's leaving work run about now. I need to touch base with Dana. Touch base with Shani, please, Arthur. You have a contact also for Chanel? Arthur D?
Yes, sir. Yeah.
Yeah, man. Touch base with Chanel until I for rope, please.
All right.
Oh, cool.
So it look like I have to call Miss Campbell to add me because I'm not getting to select that one. On the next three women and what I'm registered for. Hold on. It's there.
All right.
It's not
No
giving me the option for the list so I can choose from it anymore.
Okay.
Yes, I'll reach out to Miss Campbell. I'm gonna send her an email now.
No problem, dearest. Thanks again.
Yeah.
So there are only 3 students that I've seen. Mr. Daniel, I see that you're in class. Why when you come to class, you don't say good afternoon so that I know that you're there. You just sneak into class and don't say nothing. That's not nice. There are only
So
3
now
of you
so
that.
she's still working, training at one thing I get from Shane.
Oh,
Then
okay.
Missy or Chanel don't need working.
Okay, no problem. So there are only 3 students that have selected the class so far. Um, Hold on. I'm seeing Nesta. I'm seeing Chanel, Tony, and Shani. So only 4 of you that I'm seeing that have selected the course, and there are 10 of you. So the other 6 need to select the group, to select the class. All right, I'm going to give others a few more minutes. The rest of you, please just go through what it is that we've done so far, what we do already upon the paper. Just go through. If you have any questions, link me up, let me know when I come back. Just do what it is that you need to do. Please, I beg of you. I am begging. All right.
Mr. Sean? Mr. Sean?
You ready to tell me good afternoon, now, sir?
Yeah, afternoon.
Yeah.
This way. As it relates to what's going on, what's the status here? What should we do?
I'll get asked to ask Nesta and Otterly because I was saying that when you were in class and I was calling to you and then you disappeared. Give me a minute, please.
Okay. Otterly.
Yeah, Daniel?
Yeah, what are we supposed to do now?
Huh?
What are
Oh,
we
so not
supposed to
giving no
do?
work yet. He's not giving no work. He was just giving us some talk, but nothing. I think everyone was added to Edicasa.
Oh,
No work. We're not getting no work. I think he's gonna do a different topic or something like that. But we're not getting no work yet. Much
okay.
press.
Okay, cool.
All right, I don't think it, oopsie. All right, I don't think anybody is coming, but I'm gonna ask for your undivided as it relates to me going through. I think there are only 3 of you here. Let me go through some multivariable function. What I want to get from you now is everyone, all 3 of you around your system and are hearing me well?
Yes, sir.
Okay, that's 1.
All right.
2.
Oh, yes, sir.
Okay. All right, so good to know that you are up and about and you are hearing. I'm going to ask that I've given more than enough time to sort this out. I'm going to ask now that you look at what is happening here. This topic is going to, well, if the paper comes, you'll see it appear in 2 different areas, and it's called multivariable functions. Multivariable functions. Now, for multivariable functions, it comes under the Hessian matrix, and it also comes under an application question that is valid for 20 marks. Hear me out. And hear me out well. Whether or not the Hessian matrix comes, this other question must appear as a multivariable function. It must appear on the exam paper. Why must, sir? It is on every single calculus 2 paper. Is it just like how stationary points is on every single one of the calculus 1 paper? This is also a stationary point question. It is a stationary point question, but a stationary point question using a multivariable function, as opposed to calculus 1, where it is that we looked at the single variable function. 20 marks. 20 marks. Now, if you understand this that I'm teaching you, and I'm going to go through, by the end of me developing the different aspects of the differentiation, before the end of the class, I should go through a full question. Remember, every class I'm teaching a new topic, so I have to move. I have to move. So what I want you to do is to give me your 100%. No. Anything else that is going to be distracting you, put it on pause. Let's go. So I'm going to be looking at some first order partial derivatives. I will also look at some second order partial derivatives. But the first order partial derivative is going to be used in order for me to do the second order partial derivatives, and in order for me to do the cross order partial derivatives. So there's no way I can do the second order partial derivatives without first doing the first order, and there's no way I can do the cross order partial derivatives without doing the first order. First order is pretty easy. First order is me finding, as I have it here, f subscript x. That's my first order partial derivative with respect to x. That's my first order partial derivative with respect to x. And then I'm going to also evaluate my first order partial derivatives with respect to y. All right. So here goes. Here it goes. Here it goes. Here it goes. So if you're given a function, for example, f of xy, and that is equals to this, 4x cubed y squared plus 5y squared minus x to the fourth plus all of that. This is what we call a multivariable function. Why is it called a multivariable function, sir? It is so called a multivariable function because I have more than one variable in the function. I have several variables. In this case, I have x and y. In the other instance, when we're looking at the function, we had only a single variable function. We only have y is equals to a function in x. No, we have a function f of x is a function in x and y. So let's go. This is sharpening your differentiation skills. So it's a multivariable function because it has more than one variables. It has an x variable and a y variable. And incidentally, we have questions where we can have x, y, and z, but your syllabus does not lend itself to an x, y, and z function. It goes up, thankfully, just to x and y. All right? So this is me now again asking you for your undivided. Make sure that you are focused. I don't need you to be doing anything else, but just focusing on what I am about to do. All right. So this is when, as I said before, sharpen your differentiation skills. And I really hope that you remember how to differentiate. We have the time to go and teach you differentiation now. I'm only building on what should already be there. So let's go. F of xy. I'm differentiating this function with respect to x. I'm differentiating this function with respect to x. It's a chain with one term, two terms, three terms, four terms, and a fifth term. How do you know that, sir? These positive signs and negative signs, as in single variable functions, separate each term. All right? So what we're having here are different terms, and we are going to be differentiating accordingly. What I have done for you is to pull out the first term to differentiate. Now I'm pulling it out now, but when you are doing the question on your own, I do not expect anybody to do any pull out. What I expect you to do is to do the calculation in one go. I'm doing this only because you are doing this for the, I'm now teaching you the area, the topic. But outside of that, you're going to be so required to do the things in a one-shot situation. In a one-shot situation. Not two, nor three, a one-shot situation. All right. So look at that function for me. And when you look at that function, you see you will see 4x cubed y squared. 4x cubed y squared. Watch me. In a case like this, I am differentiating with respect to x. See here, it says f subscript x of xy. I'm differentiating with respect to x, only x. So whenever I say a y, it becomes a constant. I'm differentiating only with respect to x. So when I say a y, it becomes a constant. I'm not interested in the constant. And the differential of a constant is equal to 0. Always remember that. The differential of a constant is equal to 0. I am not interested in the constants. The differential of a constant is equal to 0. So anytime I differentiate a constant, I'm going to get 0 every single time. I'm not interested in the constant. The differential of a constant is equal to 0 every single time. Watch me.
So go over that again.
The differential of a constant is equal to 0. So
that's
when
why
I'm
I get 0.
Yes, yes, yes. So when I'm differentiating with respect to x, look at what is happening. So I normally say when I'm differentiating, and this term is called a product. So why? Because this is 4x cubed y squared. So it means that 4x cubed is being multiplied by y squared to give me 4x cubed y squared. So hear the story again. The first 4x cubed times the differentiation of the second. When I differentiate y squared, I'm going to get 0. Sir, why? Because I'm differentiating with respect to x. So anything that is not x is going to be assigned 0. So it's the first 4x cubed times the differentiation of the second, which is y squared, plus the second y squared times the differentiation of the first. Now, when I differentiate the first, I can go ahead and differentiate it because I'm differentiating with respect to x. So differentiating 4x cubed, I'm going to get 4 times 3, 12x squared. See it here, so 12x squared. 12x squared. All right. And then 4x cubed times 0 goes to 0. So I'm going to be left with y squared times 12x squared. See it here? Y squared times 12x squared. And when I do this multiplication, I'm going to get 12x squared y squared. See it here? 12x squared y squared. 12x squared y squared. That's what it is. So when I differentiate this first term, when I differentiate that first term, the differential of this first term, 4x cubed y squared, is going to give me 12x squared y squared. So this is me reminding you how it is that we do the product rule. The product rule is the first times the differential of the second plus the second times the differentiation of the first, right? The first times the differential of the second plus the second times the differential of the first. That's what the product rule says. So again, I'm having 4x cubed, and that is being multiplied by y squared. So it's going to be the first, my 4x cubed, the first, times the differentiation of the second. No, I'm differentiating y squared. When I differentiate the second, differential of a constant is 0. Why is y squared a constant, sir? Because I'm differentiating the function with respect to x. So it means that I'm going to hold y constant. Plus
So,
the second.
sir, yes, I understand that you're breaking it down so it can be easy. And you say you want it in one go, but suppose we do it like this. Is it that we have to go back and know to get if we want to do it so we can get a better understanding of what we're doing, not to make any mistake, because it seems to be if it's gonna be a one go, it's gonna be a whole heap of writing. So if we do it like this, would it be an issue, or you want it one go for the
I hear your question, Nesta. I hear your question, Nesta, but I'm
utterly.
Sorry, utterly. Why am I calling you Nesta? And I know the different voices. Oh, utterly. I hear your question, but I'm not going to respond to that just yet until I get further into the topic where you are going to even agree with me utterly. That, sir, makes sense to go through the first step here. So we can't just do it in a one go, sir, because you can't actually do it mentally. But sure, if you choose to do it yourself and you can get the right function, I am good to go. But I promise you, Arthur, you are going to be able to get it in the one shot, how it is that I want you to do it.
Sorry, can I go back to it one more time?
Sure. So I have 4x. By the way, tell me good afternoon, Miss Allison.
Good afternoon.
Good afternoon, my love. All right, let's go. So I have 4x cubed y squared. 4x cubed y squared. I'm differentiating this multivariable function. It is called a multivariable function because I have more than one variable inside. So when I differentiate the multivariable function, I need to know what it is that I'm differentiating with respect to. Since in this case I have two variables, and I can only differentiate it with respect to one variable at a time, I would have to indicate or decide which of the variables I'm differentiating this function with respect to. And my subscript, this x subscript here, is telling me that I'm differentiating the function with respect to x. I'm differentiating the function with respect to x. So it means that everything else is going to be held constant. Everything else will be held constant. Watch me. It's a product. How do you know that, sir? 4x cubed is being multiplied by y squared. So let's go. The first, see I write it back, times the differentiation of the second. When I differentiate y squared, I get 0. Why, sir? Because it's a constant. How you know that, sir? I'm differentiating with respect to x. So anything with y, I don't want it. So that's 0. Plus the second, plus y squared, times the differentiation of the first. I'm now differentiating 4x cubed. So when I differentiate 4x cubed, I'm going to have 3 times 4 is 12. And I'm going to write out my function, my variable, and reduce the power by 1. So it becomes x to the second power. When I'm fixing this thing up, 0 times anything here goes to 0. So this here goes to 0. Then I'm going to have y squared times 12x squared. Y squared times 12x squared is going to simply be this. That gives me 12x squared y squared. Agree now? You're also supposed to be around the computer, and I did my check already. So when I ask if you agree now, you're supposed to be answering, you're supposed to be unmuting to answer me.
Sir,
Yes,
what
sir.
what
Yes,
if I
sir.
y square gone? Oh, anything, you say anything to do with y?
When I
Oh.
differentiate by, I will get 0 because it becomes a constant here. No response, Ali?
Sir, when I differentiate the 5y square,
Mm-hmm.
it will be 10y.
What?
Remember, why is treated like the constants as
You're jumping ahead of me, man. I don't reach right here so yet. You're jumping ahead of me. I just
Oh,
wanted
so
to
you
get
just have the
just
first.
this part. Yeah, just this part here. Arthurlee's answer to you is correct. Very good, Arthurlee.
What was the answer, Atali?
No. Don't tell her yet, Arthurlee. Me want you to focus on this piece first. So this piece here is how we do the differentiation. Now, what it is that I'm doing here is the differentiation of everything now as a whole to get it in this line. All right. Hold on 1 minute, please. All right, so I want to just indicate this by showing that this is just a side piece of work. This piece here now is where I'm going to do the question in one go. I need to put an indication on to this. Okay, but I did say that this is a recall. All right, so this is me answering the question now. This is just a recall up here, but I use this as an example, the same example that I'm using for here. So now I'm given, I could do this. Oh, come on, this is not responding. Hold on for me, please. All right, now it is responding. All right, so this was a recall. This was a recall. All right, so I can put the recall up here. Okay, looks better to me now. So this is a question, and now I'm going to do the question. So utterly up here is when I did a recall to show you how it is that we would have done the differentiation of the multivariable function. Here now is me answering the question. So see the question here now. F of xy is equals to 4x cubed y squared plus 5y squared minus x to the fourth plus 9xy squared plus 2. And I'm differentiating. This is how I'm differentiating in one go.
Okay, so now I see why I answer me the way again.
Ah, yeah, man. So your response to Missy, I don't know why I could not call her Missy, and she needs to change our thing and put Chanel Allison on the stuff. I was responding to you. Your response to Chanel was correct. But I'm developing you in a way that I really want you to be able to do it in one go. I mean, and it's not bad. Watch me. This is my function. This is my first order partial derivative with respect to x. You won't see me write this all the time like that, right? You won't see me write as f subscript x and f subscript y. But because I'm developing the topic with you, I want you to see what it is that I'm doing and why I'm doing it the way I'm doing it. So FOPD is first order partial derivative with respect to x. I'm doing the first order partial derivative with respect to x. So my symbol is going to be f subscript x of fy. Then, sir, you have to write this. If you don't write it, only we know which one you're differentiating. So you have to write it. It's very important. Watch me now. I'm differentiating with respect to x. So it's because I'm differentiating with respect to x, it means that which other variable is held as a constant.
Why?
Very good. So y is held as a constant. Very good, Nestor. Y is held as a constant. Watch me. But my y is known as a y squared. Talk truth. Talk to me now.
Yes, sir.
Good. So I put back my y squared. I put it back because it is held as a constant. I put it back because I'm not having a conversation with it. It is held as a constant. I put it back. No, I'm differentiating with respect to x. So therefore, I now need to differentiate 4x cubed. When I differentiate 4x cubed, I'm going to get 12x squared. I'll put my 12x squared back with the y squared and I'm finished. Boom. You see here, one shot, Nestor, utterly one shot, and I give up my 12x squared y squared. See here, 12x squared y squared, instead of doing all of this. This was a basis when we were doing little school mathematics, calculus 1. But this is where we're going to go now with respect to the calculus 2 and the multivariable differentiation functions of the functions. Your response to Chanel was on point. She was saying, but I don't get 10y squared. But no, Chanel, I can't get 10y squared because this here is a constant. Why, sir? Because I'm differentiating this with respect to x. So anything with respect to y is going to be held as a constant. So the differential of this piece is going to be 0. It's going to be 0. So this one, come on, drop out of the race. Don't have no interest in that. Then I move to my other term, which is my x to the fourth. No, I can have a conversation with this because this is who I'm speaking to. So when I differentiate x to the fourth, I'm going to get 4x cubed. C3 right there, so? And it's a negative 4x cubed minus 4x cubed. When I move to this one, sir, is the same one like the first one? Yes. No, it's not the same one. Yeah, man. It is the same one like the first one because it's a product involving my x and y. Oh, it's true, sir. So this is 9x times y squared is 9. But sir, when you said then, if when we're differentiating it like this, what we're going to be doing is to remove the one that is held as a constant, which is y squared. So you put it back, see it right here, so. And then I differentiate my 9x. When I differentiate 9x, what do I get? Talk to me.
9.
And I get the 9, so I put back the 9 with the y squared to get 9y squared. And what's the differential of 2?
0.
Why?
Because it's a constant, sir.
Constant.
Talk truth. Very good. So this is my first order partial derivative with respect to x. Let me ask a question. Was that difficult?
No.
It wasn't. You may not fully get it.
Sir, I'm still a process it.
Not when you explain it like that, sir. It's not
Okay. Very good. Thank you for the compliment, mommy. All right. So let me give you another explanation. Shani just said something. So let me just give you another explanation as to why we're dismissing one of the variables when we have a multi-variable function. All right. Let us use x as wife and y as husband. So we're talking man and woman story now. We're going to use x as wife, y as husband. So wife has her bestie that come to visit. Who came to visit husband and wife? Now follow me now. Now ask a question.
Bestie.
Who's bestie?
Wife bestie.
Wife bestie. Good. So do you think that bestie is going to have necessarily a conversation with the husband? Talk to me now.
No, sir.
No, because him just come on the scene. But this Betsy of the wife, as somebody with them know from basic school, them go to the same basic school, the same primary school, and guess what? Them go to the same high school. And them go university together, them all work at the same place. So them inseparable. All right, watch me. So Betsy's having a conversation with her friend. She's not speaking to the husband. The husband is there, but the husband is not involved in the conversation. So the husband at the same room, you know, him a watch TV, and Betsy and wifey, they're on the dining table, and I have them conversation and catch up. Him not have nothing about it. So Betsy and wifey are talking and transform the conversation. So he's there, but him not taking part in the conversation. Are just Betsy and her and wifey that is taking part. In this piece here, this one is married, this one is single. So let me put a flip to this one now. This one is single, this one says, I don't feel like I want to go out today. And somebody said, come on, we could go, and say, I'm not going nowhere. This one is single, so if I'm not speaking to you, and we have a conversation because I don't know you. This one is also single, but I'm having a conversation with you because I know you. So how you know I know you? Because I'm differentiating with respect to X. You are X and you are X, so we know each other. So you're there road, and so when I had a conversation with this class already about somebody calling to you and you don't respond because you don't know the person. But if the person say, yo, Mr. Sean, what go on? Say, Bridget, in a long time I don't see, you know. In this your case again, Betsy and wifey husband having a conversation. Wifey husband is not Betsy's friend. So husband going to be a part of the environment, not contributing to anything, But wife and our Betsy having a conversation and them doing the stuff, them talking and them catching up, and there's a transformation that is taking place. I differentiating with respect to my ex. Sorry. So when you have a marriage, a couple, boyfriend, girlfriend, husband and wife, you name it. You can't just throw away one of the partners. The partner has to be there still. But you see, when you're single, if you want to cook, you cook. If you don't want to cook, you don't cook. If you feel like you know, clean the house this week, that's for you on the house business. All right? Because you're single. So when I'm single and I'm differentiating with respect to X, this is going to go full blast, 0, because I'm not talking to you. I'm not concerned about you. On the other hand, when I'm differentiating with respect to X, and this piece here is a conversation with X, I have to transform this. I have to transform that. And of course, in all circumstances, when I differentiate a constant, unfortunately, it goes to 0. All right? Okay. Watch me now with this first order partial derivative with respect to Y. Sir, is it important again to write the subscript? Yes. This is how teachers really know that, and how student also is going to know which of the variables I'm differentiating with respect to. Watch me. I'm differentiating this with respect to Y. Uh-oh. Uh-oh. And Y, that means X now becomes a constant. Oh, yes, sir, you flip it around now because you know differentiating with respect to Y. Yeah. So you see my 4x cube, I'm not having a conversation with 4x cube. So, Tori, come to bomb. So wife thinks that she alone have Betsy, husband Betsy come and husband Betsy, I talk to husband, wife have to go over her corner. So wife is whatever wife is doing, wife is here, 4x cube. And then husband and Betsy having a conversation. So because I'm differentiating with respect to Y, my 4x cube becomes a constant, so I put it back. Then I'm going to differentiate Y squared to give me 2Y. So it's going to be times 2Y. And I'm done right here. Otterly, let me pause you. Unmute, please, Otterly.
So what was the question?
Talk to me now. Out of going through all of this, let me look at this example and then come back to this one. So I'm differentiating with respect to X. This one was with respect to X. That means my Y is constant. So my Y squared, this Y squared, I'm carrying back to put right here. So not changing.
Yeah.
And when I differentiate my 4x cubed, I'm going to get 12x squared. And I put it right beside the Y squared. And it done right there. So I skip out this line and I skip out this line. See it right here again? Now this time, I'm differentiating with respect to Y, not X.
Right.
So my 4x, this 4x cube becomes a constant. So this 4x cube is this. Then I'm going to differentiate the Y squared. I'm going to differentiate Y squared. I'm going to get 2Y. See here, 2Y. Watch me now. In the first instance, we threw out the 5Y squared because we were differentiating with respect to X. We weren't concerned with the Y. No, we are. No, we are. So therefore, when I differentiate Ali, I'm going to get 10Y, sorry. So this is a 10Y that I'm getting right here. I am not interested in this X to the 4th. I am not interested in X to the 4th. Why am I not interested in X to the 4th?
Because you're dealing with Y.
Thank you. I am dealing with Y. I'm dealing with Y, therefore I'm not interested. Do I have no concern? Do I have no interest? Don't talk to me. 0. Then I come back to this one here now, but hold on, sir, you're differentiating now with respect to Y. So this 9x becomes a constant. Talk truth. See it here, so 9x become a constant. And then I'm differentiating my Y squared to give me 2Y. Boom, 2Y. And again, unfortunately, this 2 does not have a chance to survive.
Constant.
Constant. You see where the 5Y squared have a chance when I talk to Y, and the X to the 4th have a chance when I talk about X, that one they do have no chance none at all. And then all I'm going to do, this was a one-liner. This one here, all I'm going to be doing, this multiplication sign, I'm just going to fix up this piece and say 4 times 2 is 8. x cubed y to give me 8x cubed y. I write back my 10y, and 9 times 2 is 18. X times y is 18xy. So this now becomes my answer. Look at it. Tell me if this first order partial derivative you think is something you can do.
Yeah.
All right,
Sure.
watch me. I am leaving this solution 1 here, and I am projecting example 2 here. I'm going to give you 4 minutes, 2 minutes apiece to work the question for me. And then we're going to go through. I want you all to put it down on paper. For those of you who just joined, Nestor and Arthur Lee and myself had a one-on-one conversation. We're doing things differently. We're writing. We're writing because when we write, it puts the long-term memory. So I'm giving you example 2. I'm giving you 4 minutes. Don't talk in the 4 minutes. 4 minutes. 7:01. I'm coming back to you with the question. On your mark, get set, go. So I gave you 2 daughter minutes. Are you finished?
Unfair.
If you finish, let me know. Don't sit down there and expect me to know that you're finished.
I'm finished.
What you got for the subscript F subscript X?
Sir, no, I'm telling you, sir. I'm not gonna fit right, sir.
And that's why you're here. If you knew that it was right, and you would not have been doing calculus too. So talk.
No, sir, if I knew it was right, I would have tell you.
Come, let me hear what you have. Is either right or wrong? Nobody can laugh at you because all of us are in the same boat.
All right.
Mm.
I have 2y plus 10xy minus y squared.
All right. So my other question now is she correct, class? Is she correct?
Yes, sir.
So you have the same thing that she has, Daniel?
Yes, yes, sir.
Okay. Otterly, you have the same thing that Shannon has?
All right, so for my first one, the y(x), I have 2x plus what? 0 plus 1 minus 12xy. And I hear what Chanel did say. It is actually answer, Chanel.
With respect to y,
X.
X.
x, sorry, with respect to x, I have 2y plus 10xy minus 6y squared.
2y plus 10xy. Okay.
No, sir, the 2y would be correct.
2y.
I don't know. I'm asking, oh no.
Sir, I want to ask you a question.
2x
Go right
plus
ahead.
0.
So, like how them have no power, would we still keep them? Yeah.
All right. So Shani, asking a question. What is your answer to her?
Sir, based on me understand, because they were already
Yeah, no, 2y. Yeah, Chanel. Sorry, yeah.
because they were already married, or what you say? That's why I don't drop it off. Right.
Me not put no y on me not put no y on it. Me do 2y plus 10x plus 0 minus 6y squared.
So just tell me answer, yeah, man.
2y minus 10xy minus 6xy squared.
Yeah.
What?
Sir, I have
That's what I have.
No, but before I take that question, Shani, you're the one who have the question?
Yeah, I have a problem, sir. Why
All
is
right,
it
so tell me, ask me your question.
All right, so why is it 2y, sir? Because that's where I'm missing.
All right, so we are differentiating with respect to x. So that means the y is constant, so we put it back. Boom.
Oh, I get it. Oh, I get
And
it.
then now I'm differentiating 2x and I'm going to get 2.
Oh, so we're just differentiating the x. aspect.
Right. Just differentiating the one that we're interested in at the time. Yeah. So watch this one
So
now.
because the y it can't on it, we just leave it. Leave the y.
Mhm.
Okay, I get
Mhm.
I get
And
that.
guess or no? And guess or no? We not because we're married and we're best to come look for it means that we have to go dash for a husband or a wife. Because when Betsy gone back by yard, we still have to have husband and wife with you know. So watch your one here. The y here is a constant. So look at it. Boom. The y is back right here. So and then I'm differentiating.
Why they have it as minus y? I'm if it's a oh Jesus. Turning Morales, it was there a minus sign.
Second
there.
one.
Yeah.
2x.
Hold on 1 minute, please.
Okay. X, Y, let me get.
Mm.
Got this big old teddy bear right here. There's this trash next. Time because an animal with two things. When you have the trash set, that the chain. The trample powers going out the that chain. To reach the middle, let the pizza from. So the other person you would have done this year.
All right. Okay, let's go. So you see now, Shani?
Yes, sir. Okay.
Good job. Good job. So remember now, husband and wife, when them Betsy come, you know what husband will do? Okay, I can tell you. So when my wife's friends come, hi, how are you? I'm fine. Them say, oh, you look different. I say, yeah, man, me same one. You good? I know me do. Take for myself. Because she and Betsy and friends want to catch up. I don't want to be in the midst of it. So I either go in the room, go out a door, go in and go somewhere. And then now I'll get, hey, believe it now, have a wonderful rest of the day. And I mean, it's not that I'm not as I'm come and say, okay, want to talk. No, we'll have a little conversation, but I know that at some point in time, I need to take myself away because they need to talk. They need to talk. So I'm saying, watch this one here now. With that said, watch this one. 6xy squared. I'm differentiating with respect to x. So the husband is being respectful and say, here the plan. And especially if one of the siblings come by to look for her. They move to talk sibling stuff. So me take for myself. I am still in arm's length reach, but I take for myself. Then I'm going to differentiate my negative 6x. It becomes negative 6. So I just put the negative 6 beside it, and boom, it done right there. So tell me what you got for f of y, somebody. F subscript y.
2x plus 1 minus 12xy. Remember, it's 5, it's 2x. We have 1. Oh, sure.
You never multiply the 2x by 1.
The 1 by 5. Yeah.
Yeah.
All right.
All right. I want the rest of you to look at it and answer me now. Did you get it? If you don't get it, don't feel ashamed and say, sorry, I didn't get it. You know, let me know. That's why you're here. Let me know.
So,
Yes, we get the part.
So how much market this is?
Well, I'm developing the topic. By the end of this topic, it will carry 20 marks, a full question on this.
Okay.
All right, so I'm getting that you guys are getting the stuff. And example 3, come, quick and fast. I want you to do this for me now. Quick and fast, all of you, put pen to paper and start working, please.
Okay.
Augustine.
Working, sir.
Mhm. If you're finished, don't sit down there and not let me know that you're finished. I need to know if you're finished. I need to know, I need to know, I need to know.
Sir, the first one would be 12x y to 3 plus 8y to 4 minus 10xy.
Look and tell me that's what you have.
That me have to.
That me after.
Good job. Yeah, we're getting it. Nestor, done. What you get?
Xy to 3 minus 5x squared plus 2.
All right. Should I ask? Can I ask now? What it is you have for y?
Sir, my first way I did wrong, you know. let's see. 18 x square y square plus
32
x.
x.
All right, somebody else talk to them, yeah.
No, me
32
want finish it something. 32.
32 xy cube minus 5 x square plus 2.
So that's what I want to scream. So that's correct. Why are you doubting yourself?
Take us with it.
18x squared y squared plus 32xy cubed minus 5x squared plus 2. Why are you doubting yourself? Where's Reggie? Reggie not coming to class.
So this is kind of hard. I will say next one, hard thing.
No, you know how, no, let me tell you something. I want to be known as a truthful person. And when I tell you, say, normally I leave this topic. This topic comes way down in the syllabus. But as I told you, I'm doing things differently. I have not even done any applications to integration yet. I've not done that with you yet. Yes, we have questions that will come on the exam paper every year about for that. That question may come for about 10 marks, but this question will come for 20 marks. And if you get, sometimes you get other questions involving the multivariate function that we carry another 5 marks or 8 marks. So we're talking about a 28 marks worth of question on this topic. So guess what? It's a big deal. So I'm getting this out of the way first. But
So
normally
it gets harder.
it doesn't. It doesn't. So what I'm saying to you is I normally leave this because it comes way down in the syllabus. I normally leave this like the last 3 weeks of the semester to teach and students catch it. So I'm saying to you, if I do this now, exams are in August, from about the 14th, they're about 20 something August exam start. You have more than a month to catch this topic. But you must catch it. Right
So
about now, I was.
semester.
Huh?
When's Miss semester?
Soon. Soon. We just want to catch through some of these soon. So I'm saying if you have a month, to prepare yourself to master this topic, a walk in the park. An easy walk in the park. All right. Matter of fact, God help me. Daniel, did you get this?
Yes, sir.
Yeah, so contribute to the class, my brethren, and tell me say you get something. Nestor, you got it? Nestor not there. All right, I have another one. Quick and fast. When you finish, let me know. Quick and fast. Oh, we scared.
Tell me somebody to the phone.
Who wants to go?
5x4 y to the 3 minus y.
So 1 to the y to the 5th.
Oh,
So what was that?
You said 5x to the 4th, y to the 3, and then it's a minus y. Sam said 1 to the.
Y to the fifth.
y to the 5th. Yeah.
She said y to the 5th? No, she didn't.
No, I did not. I left.
Right. She said, you said 5x to the 4th, y cube, y to the 3, and then it's a minus y.
Yeah,
I was asking, right, I was asking where's y to the 5th? All right, look at it and tell me if you see the y to the 5th. Why we get y to the 5th? Sorry, Jason.
Y to the 5th in the x.
I'm differentiating x. So remember the y to the 5th is a constant, so I have to carry back the y to the 5th. And when I differentiate x, I'm going to get 1. So it's 1 times y to the 5th is y to the 5th.
Okay.
Don't worry about it. It will come to you, man. Don't worry about it. It will come.
So I'm going to leave it y to the 5th. So I add that. 3x. Yes. X plus 1. 3x to the 5 is maybe 3x to the 5. And then this is going to be y squared minus the x come back there. And then so y would be 3x to the 5. And then y squared minus x plus 1.
So which one? The f of y?
Yeah.
Look at my f of y.
3x.
Look at my.
Let me leave out 5x. Hold on, let me see. Yeah, 5xy cubed 4 to the 4. Let's see. Oh, all right. Because you had y now, so you have okay.
Finish.
Yeah. So you're not sending the document now?
Talk truth. No.
But we are right still. Me are right still. So it's fine.
I want to know about the recordings.
The recordings are being uploaded.
Really?
Yes, man. Check the YouTube channel and see what is happening. Yeah, man, the recordings are being uploaded. No, Utterly talks about the document. Yeah, man, she's correct. Because I was saying it earlier to Nesta when we were having when she had joined the class. So when I finished with you at 9 o'clock on a Friday evening, I beat up. And then come Saturday morning, I go from 9 o'clock to 12:30 again. And then I have to run out for God with the little Saturday supermarket, whatever the situation is. Beat up. Sunday gone at church. I mean, the week start, need to forget about everything else. So next, I won't even, but by the fact, weren't you supposed to send me a function necessary so I can redo a question that I lost the information about? Or I'm going to send it off to me. But yes, I'm going to make an attempt tonight to upload this document. So you're right. We can't even argue with you, Nesta. Not Nesta, utterly, you're right. But the recordings, Shani, have been going on. Just check the YouTube channel and you'll see those recordings there.
Okay, sir. Also, you can share the link back in the
It's in the WhatsApp group, you know. It's in the
It's
description
in the WhatsApp group.
Yeah, look at the description in the WhatsApp group and you'll see the stuff.
Okay, sir, thanks.
Cool. So talk to me. Are we okay now with this? Anybody wants me to go through the F subscript X and the F subscript Y? Or are you seeing the calculations? Talk to me.
Sir, run through that one here. The last one here, run through it.
No problem. I'll run through both of them. Watch
Yeah.
me. So I'm giving my function. I am doing the F subscript X. Because I'm differentiating with respect to X, my Y is constant. So my Y to the third power, I'm writing it back. See here, Y to the third. And then I'm differentiating X to the fifth, I'm going to get 5X to the fourth. See here, 5X to the fourth, Y cubed. So why put the Y, the X value before the Y? You know, it's just for the same way you wouldn't cook your rice and peas and chicken and then shake it up with the vegetable and then throw your drinks on it. That is still edible, you know, because the food cooked. But for presentation wise, we put the X before the Y in alphabetical order. So that's how we normally write this stuff in math. So that's how I write it like that. And now I'm differentiating with respect to X again. So my Y to the fifth is going to be constant because my Y to the fifth is a standalone. So I put my Y to the fifth. But when I differentiate X, I'm going to get 1. So it becomes negative 1Y to the fifth. See here? Negative 1Y to the fifth. Similarly, negative XY, my Y is constant, so I leave it as it is, and differentiate my X. Differential of negative X is negative 1, negative Y. And then I'm differentiating with respect to X. So this Y is a standalone. Boom, gone. It's gone. And then when I differentiate with respect to Y, my X is held constant. So this X here, X to the fifth is going to be held constant. And then I'm differentiating Y cubed, so it's going to become 3Y squared. So it's going to be 3X to the fifth Y squared. Because my X to the fifth is held constant. And my Y cubed, when I differentiate Y cubed, I get 3Y squared. See here? 3Y squared. So that is done. I'm holding my X constant, so I'm going to write back my negative 5, my negative X. But when I differentiate Y to the fifth, I'm going to get 5Y to the fourth. See the 5 here? And see the Y to the fourth here. It's just that I didn't write it in 2 lines, but it's the same thing. That's why I asked you to write it. I could have written it in 2 lines as I did up here. And then when I'm differentiating here, my negative X is constant, so I write it back. But when I differentiate my Y, I'm going to get 1. So it's only negative X times Y, which is negative X. And when I differentiate Y with respect to Y, I'm going to get 1. So I have my positive 1. You have another one. Pick on fast because we need to move into the others. Pick on fast.
So that's minus X to the 7.
Minus X to the 7th, yeah.
Okay.
Minus X to the 7th, right, yeah.
Finish.
Ah, good job. Let me just give them 1 more minute. 1 minute more, and then now you can share your answer with me, Shani.
Same.
Good job. All right, let's go. So Shani, tell me your answer. Well, tell not me, tell the class your answer, and then let us see if the others agree with you. F subscript X.
So first order partial derivative with respect to x is negative 7x to the 6th power y to the 5th power plus 2y cubed minus 4x cubed y to the 4th power.
All right, so that was actually Chanel. So tell me now, the rest of you agree with Ali?
What you said, 7x to the 6, y to the 5th,
7x.
negative, sorry. Sure. Yes, plus 2, what the last part?
2y cubed minus 4x cubed y to the 4th power.
Yeah.
Ali,
So
Yes,
6y, 6y.
look at the screen. Look at the screen and tell me if what I have on the screen is what you have.
So you have 2 negative signs.
There's an equal sign.
Minus 7 to the
Oh.
6.
Oh, yeah.
Y to the 5. Plus 2y to the cube minus.
Yes, sir, that's what I have.
Yeah, that's it. Yeah.
All right. So I asked you the question, Chanel, because I want to ask you, was that difficult?
No, sir, like how they are. No.
And I want to keep you right there because I want you guys to be right. It's not harder than this. It gets easier because once you understand the differentiation, you're good to go. All right. Who wants to tell me the differential with respect to y?
So me have it by saying by negative 5x and 7.
Negative 5x to the 7. That's it?
No, y4 plus 6x y cube minus 4x to the 4 y 3 to the 3.
Y cube. Yeah, I'm not.
Y cube.
Very nice. So Chanel and Arthur Lee have it. Nestor, are you back?
Sir?
Nestor, talk to me now. Are you understanding? Are you with us?
Oh, yes, sir. Yes, sir.
Shani, how about you?
Yes, sir. Getting me, but I'm
Good job. If ever you have a difficulty, please to unmute and ask me, because if you don't understand the differentiation, you're not going to be able to do the topic. Because at every point of the solution, there is going to be a differentiation. At every point, there is going to be a differential that you must do. Daniel, how are you?
So I'm all right. Understanding.
Good job. I think that is all of us. All right. You guys are okay, say. I'm going to move into the second order partial derivatives now. Okay. Can I go?
Yes, sir.
So I'm just going to show you some notations because I don't know how they're going to give the notations. And besides, when I move into the Hessian matrix, the notation here is what is going to be used for the Hessian matrix. All right. So watch me. So F subscript XY is what we've been using. You could also be using squiggly D by squiggly X of XY. It means the same thing. F of XX is the second order partial derivative that we're talking about here. And that is going to be squiggly over squiggly XX of XY. What does that mean, sir? That's the same thing. This is for X, this is for Y. So the first order partial derivative is going to be F subscript X or F subscript Y. The second order partial derivative will be F subscript XX and F subscript YY. XX because I am doing the second order partial derivatives. Oh, so the first order partial derivative only have one X, very good. And the second order partial derivative have two X's, very good. And for the Y, it has one X, one Y for the first order partial derivative, and two Y's for the second order partial derivative. Excellent. Excellent observation, excellent, excellent. All right. Hear me now. So I'm asking you to find the second order partial derivatives of f of xx and f of yy. What I want you to do for me now as a class, now in 3 minutes, is to find the first order partial derivatives of x and y. Remember, we can't do the second order partial derivative without doing the first order partial derivatives. So before I teach you the second order partial derivatives, you will have to first go ahead and calculate the first order partial derivatives. So I'm giving you 3 minutes to go ahead and calculate the first order partial derivatives for me, starting now.
Just for X alone or for Y as well? Huh?
Sorry, you know that I answer you and never recognize it was muted. No, ma'am, for both X and Y. Sorry about that.
Okay.
For both X and Y.
Finish.
Finish, sir.
All right, so I keep talking to you and not recognize it, I'm muted. Is when I didn't get a response, I look down and I recognize as muted. I'm asking, did you get that for your first partial derivative of X?
Yes, sir.
Good job. All of you, the rest of you, talk to me.
Yes, sir.
Check it. Hold on. First one, 12 x squared y to the 2 minus 4x to the. And yes, sir, yes. Second one, 8x cubed, it was 10y, 18x. Yeah.
All right. Now, look at what I'm, and is that the same thing you got for Y? Look at Y and look at my Y and tell me if you
Yes,
got that.
sir.
Yes, sir.
Good job. All right. So let us now do, so that's my first order partial derivative. All right. So I'm going to be looking at my second order partial derivative now. And I want you to watch me. I'm going to do this just once because you must catch it. So I'm finding xx. So because you already have f subscript x, I'm going to differentiate x one more time to get xx. In order to get fxx, I have to differentiate fx once more with respect to x to get xx. So watch me. So I'm differentiating, the y becomes a constant, so I put back my y squared. I'm going to differentiate 12x squared, I'm going to get 24x. See here, 24x. Differentiating with respect to x. 3 times 4 is 12x cubed, squared, 12x squared. Differentiating with respect to x. No x, 0. That goes. Look at my y. I'm differentiating my y once more in order to get my y. So I'm differentiating y with respect to y in order to get my y. Differentiating with respect to y means that my x is constant. So I'm going to write back my 8x cubed. See here, so? I'm going to differentiate y, I'm going to get 1. So 1 times 8x cubed is just 8x cubed.
No, Pierre? Eh?
Yeah, thank you, Missy. All right. So what is happening here now is, so when I differentiate 10y with respect to y, I'm going to get 10. And when I differentiate 18xy with respect to y, my 18x becomes a constant, so I write it back. And when I differentiate y, I get 1, and that is it. So this is my second order partial derivative. Look at it and tell me if you are agreeing with what it is that I have on screen, please.
Yes, sir.
Yeah, man, not bad. I promise you, I'm not lying to you. Promise you. Waiting for the others of you to agree or disagree with me.
All right, taking it in.
All right, no problem. I'll give you a couple minutes to do that. We're staying.
So continue.
All right. So I have an example today's class, incidentally, I didn't tell you, but today's class is you doing a lot of the work. I want to explain and you doing a lot of the footwork. So I want you now to find the second partial derivative for me of that given function. Remember, you have to go to the first order partial derivative, and then you do the second order partial derivative. So I'm gonna ask you now to go through the full gamut of that. First and second order partial derivatives of that function. Start for me, please.
12 weeks. Finished.
Nice job. Nice job. Anybody else? Hmm.
Finished, sir.
All right. I'm projecting some things here. I project those two. Look at those and tell me if you agree with me, please. If you don't agree, you just say, sir, I did.
Yes, sir.
Good job. Shani, how you still you're not talking to me?
Sir, I'm trying to get some food for two little young girls I have, but I'm trying to follow still.
All right, no problem.
Yeah.
What about the rest of you?
So I'm just working, just stepped away.
Okay. Always stay, always stay, always stay.
Sure, stay good. You're gonna start our next topic for tonight?
This don't finish yet, you know. I'm building because I do the first order partial derivative. I'm doing the second order partial derivative. I now need to look at the cross order partial derivative. But before I go to the cross order partial derivative, I need to give you one more second order partial derivative just to make sure that you are where you are supposed to be. So somebody just joined a while ago. Who was that?
I want them back something there.
Oh, Shane, came back in. All right, don't worry about it. It's just the notation. I don't know which of the notations they will give you, but look at it. Is it the one x down here so? It means the first order partial derivative. Is it the two x them down here so? It means the second order partial derivative with respect to x. Is it the one y down here so? It means the first order partial derivative with respect to y. And the two y them down here so means the second order partial derivatives to y. So it's the same thing I was telling you about up top, but just a different notation. Don't know which notation they will give you. So I have to introduce you to both notations. All right? You have another question. There you go. Start from it, please. If we get this one, I'll move into the cross order partial derivatives and then move into a full question. I'm finishing this topic tonight, so we have a couple of minutes to go through.
Sure, so that 8 over 8x.
No, ma'am.
Sir, I want them to give them something there, no, sir.
All I'm saying to you, Ali, is this is a function. This is a function. And when you see squiggly d over squiggly x, this squiggly d is saying that it's not a full d, it's only a partial d. So it means that they're asking to calculate the partial derivative of the given function f of xy. So you're doing a partial derivative with respect to x. So that's what they're asking you to do. So this is not 8 over 8x. It's a partial derivative with respect to x. So do that with respect to x for me, and then again with respect to xx, y, and yy.
Sir, send this one finish, please.
Will do, hon, will do, will do. Stay.
Finish.
Good job. Nesta, I don't like when you're so silent, Nesta boo. I don't like when you're so silent. Look at the first order partial derivative, as well as the second order partial derivative, and tell me if you agree with me.
Yes, sir.
Good job. Good job. That's what I like.
No, sir.
All right, somebody says no. All right, so there goes an opportunity for us to have a conversation. No. Why no?
Sir, for this second order derivative for y. Oh, never mind.
You see no?
Yes, sir.
Waiting to get confirmation from the rest of you.
Yes, sir, got it.
Good job. All right. I'm giving you one last one. You know why? I'm not so convinced. You do this one and I hear the class say to me, yes, sir, I got it. I'm moving to the cross order partial derivative so I can finish off the full question. Very good though. I know you get the first order partial derivative and I know that, but I'm not so convinced about the second order, even though that you're just differentiating it once more. But go ahead and let me see this one quick and fast for me, please. When you finish, let me know.
Finish.
Finish, sir.
Always stay.
Finish.
Tell me if that's what you got.
Yes, sir.
Mm-hmm. What about the rest of you?
Yes, sir.
Good job. All right. So not really not one, not really not one. I'm going to move to the cross or the partial derivatives. All right. So I'm moving to cross or the partial derivative. All right. Do me a favor. I'm giving you this one here. I'm going to be introducing the cross order partial derivatives now. But remember, in order for you to do the cross order partial derivatives, you'd have to go through the first set of calculations. So what I want you to do as practice for tonight's class again is to use that function. You're going to find f subscript x, f subscript xx, f subscript y, f subscript yy, and then I'll take you into the final aspect of this differentiation, which is the cross order partial derivatives. And then when I do that and I feel like you're comfortable with that, then I'll do a full question with you. All right. So whenever you get a question like this, a stationary point, you are going to have 6 calculations to do. F subscript x, f subscript xx, f subscript y, f subscript yy, and then the 2 what I'm going to teach you now. All right. So do that one for me quick and fast. Do the first 4 for me quick and fast, and then I'll show you the last 2. Thank you.
Finish.
All right. Well, the rest of your work, I'm projecting those. And did you get that one? Or those?
Sir, why was still right about the 16? The 16 was supposed to 0 out.
Check that one again for me, please.
Sir?
No, I'm saying to check that one again for me.
Oh.
talk to me now, Missy. You agree with my 16 now?
No, sir, no, I'm still not get it.
Anybody agrees with my 16? I mean, like how the rest of the son, like when I want to sleep on the teacher, you know.
So yeah, psychic.
I know it's a Friday evening, and you know, I know. Come on, we're soon finished, man. I'm just beginning for 20 more minutes. Did you get F? What you got for F subscript Y? Chanel?
I got 6x squared minus 12xy squared plus 16 plus 1.
16y plus x, not 1. 16y plus x.
So I'm gonna differentiate the 16y.
And get what?
16. All right, hold on. For the first part.
No, hold on. Let me look at what. No, you had 8. Okay, let's go. So you had 6x squared y. So we're differentiating with respect to y. That means the 6x squared is a constant. So I'm writing out my 6x squared. Then
Yes,
when I
sir.
differentiate y, I'm going to get 1. All right, so that's why I have this here.
Yes,
Then my
sir.
4xy cube, I'm differentiating with respect to y. So my negative 4x is a constant, so I put it back here. Differentiating y cube, I'm going to get 3y squared times 3y squared here.
Yes.
Then I'm going to differentiate with respect to y, so it's going to be 8y squared, so it's going to become 16y. See here, 16y.
Yes, sir.
And then I'm differentiating with respect to y, so I'm going to put back my x, and differentiate of y is 1. Then I'm fixing up this to give me 6x squared times 1 is 6x squared. And negative 4x times 3y is going to be negative 12xy squared. See here, 12xy squared. And then 16y, and then x times 1 is x. So this is what I get for my.
Sir, why you right about 16? Why not supposed to differentiate?
I differentiate, I don't differentiate it yet. I differentiated before to get the 16y. See, I had 8y squared up top in it.
Oh, well, I differentiated it there. Okay.
Yeah. So it's when I differentiate the 8xy squared, I got my 16y. Then when I differentiate this now a second time with respect to y, this 6x squared goes to 0 because there's no y there. And differentiating with respect to y, I'm going to write my negative 12x, see to yourself, boom. And then I differentiate y squared to give me 2y. And then the differentiation of 16y with respect to y becomes 16. And this x goes to 0. So I'm left with that. Look at that for me, please, one more time, and let me know what it is that you have.
Yes, sir, that will have.
Yeah, good to go now.
Sir, I want to sleep. I'm going to drive go home.
No worry about it, man. 10 more minutes. I'm 15 more minutes. 15 minutes, 15 minutes. All right, so before the rest of going to drop asleep on me, let me just do at least this piece. I don't think I'm going to be able to finish this stuff, but let me at least do the last piece of it. The last piece is not difficult. So recall that you must use the first derivative of the original function to evaluate the following. Look, watch me and watch me carefully. I am now evaluating the cross-order partial derivative. The cross-order partial derivative. The cross-order partial derivative. So we look at first order partial derivative, second order partial derivative. I'm now looking at the cross-order partial derivative. Sir, what is cross-order partial derivative? Okay, thanks for asking. Watch it. You notice I have f of xy, and then I have f of yx. So in order for me to calculate f of xy, I'm going to go to f of x, which is up here, and then I'm going to differentiate it with what I end with here, which is y. So f of xy, I have to look at f subscript x and then differentiate it with respect to y. And that's why it's called the cross-order partial derivative. That's why it's called the cross-order partial derivative, because I'm not differentiating the x with the x again, but I'm now differentiating x with respect to y. So let us go with the cross-order and do the y. Differentiating with respect to y, that means my x is a constant, so I'm going to have 12x. When I differentiate y, I get 1. I'm differentiating with respect to y. So this now becomes 3, 4 is negative 12y squared. And when I differentiate y, I'm going to get 1. And let us double check. And let us do the cross-order partial derivative with respect to y. I'm differentiating with respect to x, I'm sorry. When I differentiate with respect to x, this becomes 12x. See it right here, so? With respect to x, my y squared is a constant, so I put back my y squared. And when I differentiate negative 12x, I'm going to get negative 12 right here, so. When I differentiate 16y, I'm going to get 1, and differential of x is going to be 0. And what do you notice with my cross-order partial derivative? F subscript xy and f subscript yx. What do you recognize?
They're the same.
They are the same, and they will always be the same. So what the mistake I don't want you to do is to go ahead and calculate f subscript xy, and then the answer you get, you just write it back for yx. Because when you differentiate yx, if you get a different answer than xy, it means that something in your calculation up top is incorrect. Now, when I do my xy and then do my yx and get the same result, it is telling me that what I did from up top is all correct, and I don't have to worry. But it is important for me not just to calculate yx and call it a day. I have to calculate yx as well as xy. When the two of them lines up, I am good to go. Answer me this. Do you understand?
So I go through that one more time.
All right. My pleasure. I am doing f of xy. F of xy. So it means that I'm going to be looking at my subscript f subscript x and differentiate it with respect to y. X and then differentiate it with respect to y. Give me half a second, please. Come in. All right. Ottilie, you still awake? You can say, if you're awake, Ottilie, say I. I guess she's
Right
not.
away.
Okay, good. So you wanted me to go through this again? That's what they said, right?
Correct, correct.
All right, so this is it. So I'm differentiating to, I'm finding f of xy. F of xy, I have to use f subscript x. I have to use f subscript x in order to calculate xy. I have to use f subscript x in order to calculate xy. So I'm color coding them for you. So f subscript x is what I'm using here to calculate this down here. So anywhere I see f subscript x, I'm going to differentiate it now with respect to y. And that's where the cross order comes into play. The cross order comes into play because I'm doing the opposite variable. So I'm differentiating this respect to y. So that means my 12x is a constant. So I write out my 12x. And the differential of this y is 1. So 1 times 12x is simple, 12x. And I'm differentiating with respect to y, so I'm differentiating this. 3 times negative 4 is negative 12y squared. Negative 12y squared. And when I differentiate y, I'm going to get 1. So this is going to be my cross-order partial derivative for xy. And in order to get my yx, I'm going to differentiate this one with respect to x. 2 times 6 is 12x squared. Sorry, 12x. So I'm going to have my 12x. And when I'm differentiating this here with respect to x, my y squared is a constant. So I write back my y squared. Boom. And then I'm going to differentiate my negative 12x to give me negative 12. So it becomes a negative 12x, negative 12y squared, sorry. And then I'm differentiating this here with respect to y, with respect to x, sorry. So it becomes 0 because there's no y there. And when I differentiate my x with respect to x, I get 1. So I get back the same thing. Let me know if you see it now.
Yeah.
So if when you do the calculations, guys, and this here is different from the one down here, it means that you are wrong. Never, ever, ever work out f of xy first, and then you're going to decide in your headspace that what you're going to be doing is to write it back for yx. When you do both calculations and both calculations come out to be the same thing, you are good to go. All right? I'm going to stop here. Tell me if you see what is happening.
So far, sorry.
All right, good. All right, thanks for coming out. I know it's a Friday evening and people try to get home first, but make sure that you're accessing the recordings, please. The recordings are there. Make sure that you're accessing the recordings, especially if you've missed the first part of the class. All right. All the best.
So the canvas up? Not
Erica,
canvas. Erica up?
yes, miss.
Sir, next question, next thing. Sir, now some name spell. I will change it.
I mean change it, but me just write on something. Oh, it's spelled C-H-I?
2 N's, 2 N's, 2 L's, 2 E's. No E at the end.
Okay, got you. We'll do it for you, but it's me change it. Thanks for the correction.
Okay.
Cool.
Sir.
Go ahead, Danny.
All right, so it was requested that calculus 1 would be override so that I can choose select calculus 2. Are you seeing that request, sir?
No, but you don't need to get an override for calculus 1.
Well, that is what.
All right. All right. No problem. Just I'll look for it.
All right, sir.
Bye, people.
All right, guys. All the best here. We'll talk. Oh, them gone already.